Topic of this video is to now start looking at the neutralization reactions that happen between acids and bases. When an acid reacts with a base, a neutral product is then formed, and a neutralization reaction has occurred. Neutralization reactions are double displacement reactions. We've seen those. And a good example is that antacids react with stomach acid to neutralize the acid. And so when you get heartburn, that's because some of the gastric acid, the hydrochloric acid in your stomach, starts to reflux up into your throat, acid reflux. And acids then react with that stomach acid and neutralize it, forming a neutral product, and so your throat feels better. Some of the very common bases used for neutralization reactions are ionic compounds that contain either hydroxide or the hydrogen carbonate ion or the carbonate ion. Those are some of the common bases that might be used. And so we can see here sort of our classic double displacement reaction. We have NaOH reacting with HCl. And so we have our positive ion from one, the Na, reacting with coming together with the negative ion from the other, the Cl, to form NaCl, a neutral salt. The H from our acid coming together with the OH from our base to form HOH, which is just another way of saying water, H2O. And so if equal numbers of moles of each of those come together, then our result is a completely neutral solution. In this case as well, the sodium and the chloride ions are unchanged during the reaction. So remember, this aqueous here means this is dissolved in water. So this is just Na plus and OH minus. Similarly, this is H plus and Cl minus. So we have an Na plus and a Cl minus just floating around. This NaCl aqueous also means this is dissolved in water. This is an ionic salt dissolved in water, so it's split up. That aqueous means that it's Na plus and it's Cl minus. And so those don't change from one side of the reaction to the other, and so we call those spectator ions. They're just sort of hanging out in there, excuse me, while the H plus and the OH minus come together. We can see here what we call the net reaction. In a net reaction, we write it without writing the spectator ions. We write just sort of what's happening chemically. And so in this case, we have our OH minus coming together with our H plus to form H2O. And so this would be the net reaction for any acid-base reaction. Anytime you have a hydroxide base coming together with an acid that's going to put in some H plus, so any of your classic acid-base reactions, this will always be the net reaction, no matter what type of hydroxide you're using or what your acid is. This would always be your net reaction. We haven't talked about polyprotic acids, but polyprotic acids are those that can contribute more than one hydrogen. And so something like sulfuric acid, let's just take a look quick at. So sulfuric acid, H2SO4, so plus water, that can form HSO4 minus and our H3O plus. So we've seen that before. That HSO4 minus can still go on to react with more water to form SO4 2 minus. And H3O plus. And so that can happen, can happen twice, meaning that H2SO4 is what we call diprotic. Not sure why my Apple Pencil is dying here and why it's not writing. There we go. Because it's got two of those H's to donate. Phosphoric acid could add 3. H3PO4. Citric acid can also add 3. And so in those cases, when we're looking at the neutralization reaction, we need to have enough of the base to react with both of those, because one hydroxide ion is needed to react with each of those acidic protons. And so in this case of a reaction between NaOH and H2SO4, we need 2 moles of NaOH. which will then give us 2 water molecules, and our ionic compound would be Na2SO4. Again, sort of our classic double displacement reaction. So like I said, neutralization reactions occur when an acid combines with a base. Actually, we've talked about all of this. So this slide is just the same information. So here's our net reaction again, OH minus plus H plus gives us H2O. We do have to note that if our base is CO3 minus or CO3 2 minus or HCO3 minus, that will eventually form carbonic acid. And so if we have H plus and HCO3 minus, that forms this carbonic acid, which does go on to break down almost immediately. Carbonic acid is very unstable and will break down almost immediately to form H2O and carbon dioxide gas. And so this, you would see bubbling in this sort of reaction. And we should also note that antacids often contain carbonate ions. So you might get a little bubbling with your antacids. Another type of acid-base reaction is ammonia. So any type of ammonia product, that contains something like NH2 and something else connected to it. And organic amines, those will react with acids to form what we call ammonium salts. And we can see that better down here. So we can see this big compound here, ephedrine. If we react this with an acid, what's going to happen is this hydrogen here from the acid is going to now attach to the nitrogen, and the Cl just kind of floats around as a spectator ion on the outside. We can see that here just floating, not connected to anything. But we can see our final compound here, which we call the hydrochloride salt of ephedrine. This is a reaction that's quite often done in order to have some sort of compound. So this compound here, ephedrine, and I forget what it would be used for. It's a type of adrenaline, I believe. But if we need to introduce this into the body or introduce this into a solution to be able to deliver it as a medication, this isn't real soluble. We're going to have a hard time getting this to dissolve in water. We react it with the acid though, and now this hydrochloride salt, this will dissolve in water. And so this type of reaction is quite often done to what we call, in order to solubilize amines. So it'll take this amine, and we'll learn what amines are in a few weeks. It'll take this amine and put it into a form in which it will dissolve in water. That's why sometimes if you've got some medications, take a look at the actual medication name. Sometimes you'll see the name of the medication and then hydrochloride. And that's what it means. They've had to take the drug that they're trying to give you and react it with some HCl in order to form the hydrochloride salt. That then gets it into a form that they can then put into your medications. So this was just a short video looking at our acid-base neutralization reactions. And so that is all for today. Haven't got my new closing yet. And so I'll just say, I hope you're all having a good day.